So a limit just means you're approaching something, right? So in all of high school, you thought about like when x equals 3, then f of x equals blank or something. Let's say f of x is x squared. So
Yeah.
how would you do this? I think you know how to do this.
When x it would be 9.
Yeah, because you just plug 3 into x, right? But then limits is asking a different question. So this is when x approaches 3, then f of x approaches blank. We're going to say f of x is the same thing. How do you figure out? How do you figure this out? Because it deals with approaching instead of equaling.
Yeah.
Let's say that x is 2.9. Oh, wait, let's say that x changes. Now it's 2.99. Oh, wait, let's say x changes again. Now it's 2.999, right? X is getting close
Yeah.
to 3. It's approaching 3. Okay, so when that happens, what does f of x approach? So I would have to like plug in these numbers to f of x.
Yeah.
Have you seen somebody do this before?
Yeah, when we first introduced limits, that's what they did. They would do like closer and closer from the positive side, and they'd do closer and closer from the negative side. And then the
Yeah, yeah,
numbers would like
yeah.
match up.
Yeah, because you could even do it from this side. You could get closer from like bigger than 3. Yeah, exactly. All right, so you would have to like plug in all these numbers into f of x. So literally like 2.9 squared, right? Just plugging 2.9 into x. And if you do that, you end up getting like 8.41. And then you could do 2.99 squared. If you do that, you get 8.9401. And you could do 2.999 squared, 8.994001. So what does it look like f of x is approaching here?
9.
Yeah, it looks like it's approaching 9. I mean, we don't know for sure actually, right? I mean, who knows? Maybe it's approaching 9.00000001. Like, I mean,
Yeah.
that technically could be true, but we're gonna guess that it's 9. And then,
Hmm.
like you said, there's like a negative side and a positive side. You know, you can approach 3 from under it, or you can approach 3 from above it. So we should also do this one and make sure they match up. They have to match up for the limit to actually exist. So if you do this, you get some value.
9.61.
9.61. Nice. 3.01, I think that's
Yeah.
9.0601. So looks like we're also approaching 9 here. Looks like it. Once again, I mean, I guess we're kind of guessing, but it looks like
Yeah.
we're approaching 9. Turns out we are correct. It does approach 9. Of course, then, a lot of people would say, what's the point of thinking of approaching when it just gets you the same result as equaling, right? In both cases, we got the same result. We got 9. Like,
Yeah.
what's the point? Why make this distinction between equaling and approaching if we end up just getting the same result? The answer is because it doesn't always get us the same result. We're actually kind of lucky if we get the same result. And so,
Okay.
mathematicians were like, if we get the same result, that's special. We should come up with a word to refer to that. And the word they came
Yeah.
up with was continuous, right? Continuous means,
There's no like breakage in like that curve. It just keeps
yeah,
going.
yeah, if you want to think of it visually, if you have a curve and the curve just, never has any breaks or any gaps or whatever,
Yeah.
then yeah, it is continuous. But think about what that really means. That means that if it looks like we're approaching a certain value along this curve, we actually end up getting there. We end up actually equaling that value.
Yeah.
If we're approaching something, we eventually want to equal it. That's what continuous means. Okay. It's
Hmm.
never like, oh, it looks like we're approaching a certain number and then psych, we're actually going up
Uh,
here now or something, right?
yeah.
That never happens, right?
Yeah,
Uh,
that'd be discontinuous.
that would be discontinuous, right? There's a gap there. Okay, here is an example of a function is not continuous. Approaching and equaling do not get us the same result. When x equals 3, f of x equals plugging 3 into x. Ooh, this is weird. 0 in the denominator means undefined. You can't divide by 0. Now, let's talk about approaching. When x approaches 3, what does f of x approach? So we should probably do this the same way we did the other one. Plugging in 2.9 here, you get 5.9. Plugging in 2.99 here, you get 5.99. We're approaching 6, it looks like. We're
Yeah.
guessing we're approaching 6. Maybe we're not actually. The guess, we could be approaching 6.0001 or something, but I'm guessing we're approaching 6. If I plug in
Yeah.
3.1, I'll get 6.1. If I plug in 3.01, I'll get 6.01. It does look like we're approaching 6. So there you go.
Right.
Approaches 6. We got a different answer. This is 6. This is no answer. It was undefined. So equaling and approaching do not have to get us the same result. That's why people care about approaching. Let me zoom out so we can see the line. It is a line. Yeah. At 3, something weird happens. Whoa. It's a hole. Undefined. So
Yeah.
yeah, this is a hole. Now, there is a fancy math word for this, because of course there's a fancy math word for everything. This is called a
Yeah.
removable discontinuity.
Okay.
You can have functions that have, you know, gaps in them. I think absolute value of x divided by x has one. Yeah, look at that. It
Oh, that'd be
jump,
the jump discontinuity.
the jump discontinuity. Okay. Hello, everyone on YouTube. My student just left. We ran out of time, but there are two more important things that I feel like I have to mention in this video. The first thing is notation. When people write a limit question, they're not actually going to write it like this because that's too much to write. So there's a way of writing this with a bunch of math symbols. This is it. So I know this looks confusing. Maybe there's symbols here that you're not familiar with, but it's a lot less to write than writing this whole sentence. So once you get used to it, it's actually much more convenient. Okay, so first of all, the way you read this is the limit as x approaches 3 of f of x equals 6. That's the way you read it, and it means the same exact thing as this sentence. When x approaches 3, then f of x approaches 6. Of course, f of x is really just this fraction here at the top. So I could just write this if I wanted to. Whatever. They both mean the same thing. All right. The second thing, let's go back to the other slide with all the writing on it. Okay. I regret to inform you, you will not be allowed to do limits this way in your calculus class, like on a test. This is what limits in theory are, and it's really important that you understand this. This is not actually the way that limits are done in practice in calculus classes. Okay, here's the reason why. In the end, we had to make a guess. Right here, we had a guess that it was approaching 9. Right? It could have been approaching 9.00001 or whatever, but we guessed it was approaching 9. And then here we guessed it was approaching 6. And the thing is, mathematicians hate guessing. Guessing is like the worst thing for mathematicians. Okay? Mathematicians want to know that something is true with certainty. Right? They want to be able to prove something. They don't want to make guesses. So what mathematicians would rather do is give you a bunch of formulas and a bunch of rules. And they have proofs of them, like literally, there will be proofs of them in your textbook. And then all you have to do is just use those formulas, use those rules, and compute the answers to limits. And you never had a guess. You're just using these formulas and rules that have already been proven. So you know that your result is correct. No guessing was involved. You know that you're correct with 100% certainty. These are formulas and rules for finding limits that you might see in a typical Calc 1 class. I don't have time to talk about this stuff because this video is already long, so I'll put links to resources that can help you with this stuff in the description below. Also, you might not need to know all this stuff for your Calc 1 class, so check with your professor. Also, this one in particular, this is taught way later than the rest of this stuff, like an entire 2 chapters after the main limits chapter. So, just be aware of that. Anyway, that's it for this video. Thanks for watching, everyone. I'll see you in the next one.